Right. Assalamualaikum. Good morning, everyone.
Morning, doctor.
Okay. I hope you guys are doing good. Yeah. So we resume our lecture on LU3. So last week you guys have covered part 1, I suppose. So LU3 is about one-way ANOVA. Okay. Let me just go through the important points for part 1. Okay. So LU3 is entitled One-Way Analysis of Variance, ANOVA. That's the short form of it. So in part 1, I suppose we know what is ANOVA, why we do ANOVA. ANOVA is a type of statistical test. So remember, in statistics, there are many tests, and each test is designed for different purposes. So before this, we have covered t-test. T-test is used for comparing two samples or two groups. Sometimes we compare one sample and the population. We have also a situation where we compare two samples derived from two populations. So those things are, we call it groups to be compared, okay? But what happens if, let's say, we have more than two groups or two things to be compared? We cannot use t-test anymore because t-test is designed only for two groups of comparison. So for more than two groups, the statisticians have designed another test, which is called ANOVA. Okay, so that's why we study ANOVA. So you have to know, first important thing that you have to know what is ANOVA and why it is created. Okay, so it is created for comparing not just for three groups, it's as long as it's more than two groups. So it can be four samples, four groups of comparison, 5, 6, 3 is the minimum, and it could be more than that. Okay, but the higher the number of groups to be compared, of course, it would be more complex because there are many things to be compared, and you have to know which one you are comparing. Okay, unlike t-test, when we only have two groups to be compared, it's very easy, A and B, B and A. So there's nothing more. Okay, so ANOVA is in other words, is more complex than t-test. So why we have to study ANOVA? Because in science, we are going to have not just two things to be compared, we're going to have more than two normally. Yeah? More than two experiments, more than two places to be compared. Yeah? So that's why we need to know what kind of test that is suitable for comparing more than two groups. So that is the basic of ANOVA. Is used for comparing more than two groups. Okay, so so here we are going to cover one-way ANOVA. So what is meant by one-way ANOVA? There are two different types of ANOVA, one-way ANOVA and two-way ANOVA. So what is meant by one-way and two-way is it referring to the factor or variable. Okay, so what does the factor or variable mean? So if let's say we want to compare the things that we want to measure, the things like the height of students from faculty A, faculty B, faculty B, C. So that height is the variable, is the factor. Okay, so if let's say we want to compare other things, like maybe the number of books read by the students from school A, school B, and school C. So the number of books, that is the factor, the thing that you measure. Okay, and the samples are different. The sample referring to the groups that you compare. Okay, so one-way ANOVA is a test that is designed for comparing one factor, one variable, involving more than two groups. Okay, so one way. But if we have more than two things to be compared, if let's say you want to compare, let's say you are talking about insects from 5 places, and you want to compare maybe the weight and the height of the insects that you have sampled from 5 different places in Sarawak. Okay, so you have two things that you want to compare, the weight and the height. So that the factors, there are 2 factors. So in that situation, you have to apply two-way ANOVA, okay, the test. So it means that you can compare the two things of 5 samples at the same time. But in this LU, we're going to just focus first on one-way ANOVA. Okay. So that's what that way stands for, or is meant. Okay. Okay, and then of course, samples, how many things that we want to compare, that refers to we call it samples, but in ANOVA we would refer to the term treatments. Yeah? Treatments. So there is another term that we use in this chapter, but treatment and samples are the same thing. But it's just that we don't say samples anymore. We call it or refer it treatment or groups. Okay, groups. Okay. So by right, you should know that these 3 things actually refer to the same thing. Okay. So those are the terminologies that you need to take note. Okay, what are the assumptions for one-way ANOVA? The variance of the populations must be equal. And then the samples must be independent, means that the sample stands by its own. It does not, is independent. It's not related to each other. And then the populations from which the samples were obtained must be normalized or approximately normally distributed. So that's the assumption. We assume that because when we compare the samples, we assume the samples come from population. So if let's say we have 3 samples, we assume that these 3 samples come from 3 different populations. So our assumption on the populations where the samples are derived, we assume that it is normally distributed. Means that the data is, in general, it will look like a bell shape. Okay, so from the lowest value to the highest value. So the middle value stands in the middle. So that's what it meant by normally distributed, the whole distribution. Okay, so what is important in the first lecture that I asked you guys to watch the recorded lecture. So the key points is that you should know in ANOVA analysis, you should produce this table, which is called ANOVA summary table. So means that you have to generate it and you have to calculate the values inside it. So what are the values inside this table? Degree of freedom of treatment, that's the first thing. Degree of freedom, DF stands for degree of freedom. Okay. The second thing is degree of freedom of the error. Okay, before that, on the first column, we must have these things, treatments, errors. Okay, those are things that you have to know in this table, treatments, errors, and then the second column is degree of freedom. So you have to find out degree of freedom for treatment and error. And then the third one is sum of squares, or SS, yeah? Sum of squares. So you have to find for the treatment, which is denoted as SST. Okay, the sum of squares of the treatment. SSE, sum of squares of the error. So this is the third value. This is the fourth value that you have to find. Mean squares. Okay, the fourth column is mean squares. You have to find the mean squares of the treatment, which is denoted as MST. This is the fifth value. Mean squares of the error, MSE. Okay, and the last one is you have to find what's the F value, and this F value is also known as F calculated, because you calculate the thing. So, and to reach the F value, you need to make sure that the values that you have calculated for the whole thing here is correct. ST, SSE, DF, SST, SSE, MST, MSE, because the F value here will be equal to MST divided by MSE. Okay, to find MST, you have there is a formula for it. I think if you go through the lecture, then you know that the MST depends on SST, SST depends on the degree of freedom of the treatment. So at the end, all the values inside the table, it will affect the F value. So if you got incorrect values for MST, SSE, so you would get incorrect value for the calculated F. Okay, so that's why it's very important to make sure that all the values in this table is correct. Okay, because you need to get the F calculated. So these are the values that you have to solve, and you have to construct this summary table in your workout. Yeah. So what's more? Okay, so the steps for the ANOVA. So these are all the steps, and it's not actually a separate thing from the ANOVA table. Okay, if you go through the steps here, so it's quite long. There are 14 steps, and the whole thing here, like for example, starting from step 2 until step 11. If you see here, these are actually these are the steps that are required for constructing the ANOVA table. Okay, ANOVA table. So it's actually, you know, these are the steps that you need to perform in order to do the analysis and at the same time to produce that ANOVA table. ANOVA table is part of the steps. Okay, so let's have a look at the steps. Okay, so for any tests in statistics, there are various, there are several steps that you have to undergo. Like for example, before this all the tests that you have covered before, there are steps, right? So you have to know for each test what are the steps. For this ANOVA test, the first step, like any other test, is to make hypothesis, the null and the alternative hypothesis. Yes, and you can see that that is the very basic step in any test. Okay, and if you see the last step is to make a conclusion. It's always the same for any statistical test. The first step is to make hypothesis, at the end to make a conclusion, because you want to actually, at the end, you want to say something about the data. What is actually the same? Which one is not? Huh? And of course, in the beginning, you must have your hypothesis. You must have your expectation about the data. Which one is the same? Which one is not? And statistics is all about comparison. We want to compare the things. Okay. Step 2, calculate the degree of freedom. Okay, let's go through first. Step 3, find mean of each group and treatment. So when you are given any problem, you have to identify from the data what are the things that you want to compare, which means that will tell you how many groups or how many treatments that you are dealing with. Okay, so that's why you have to understand the problem. It's very important for you to understand the problem. And the problem given to you is not that really difficult. It's about comparing this, comparing that, but you have to understand specifically because one problem is different from another. And you have to state the terms in that problem specifically. You cannot say that group 1 is not equal to group 2. You just mention, like, if let's say it's about comparing fertilizer, then you have to mention fertilizer A is not equal to fertilizer B, okay, according to that problem. So you cannot make it general. So what is the rationale of it? So whenever people report to you anything on the newspaper, they would say the thing specifically, right? For example, the number of patients from hospital in Ipoh, number of patients from hospital in Kuching, for example. So they don't say that number of patients from hospital A, hospital B, hospital C, what hospital A? So at the end, we want to communicate the information to the public and we want to tell something. So we cannot just denote A, B, C, or 1, 2, 3. Otherwise, it's going to be pointless. Yeah? So that's why we have to start from when you study statistics, you have to state the problems specifically. Right. Step 2, calculate degree of freedom. Step 3, find mean. Step 4, find overall mean. Okay. Just go through first, and then I'll show later. I'll guide later what all these steps are all about. Okay. Step 5. Okay. Step 5 to Step 5, Step 9. So these are actually all the steps for you to find all the things inside the summary, the ANOVA summary table. Okay, so you can see step 10, find SSE. Step 11, calculate MST, MSE, and F values. Yeah, remember the F values in the ANOVA table, and that is equivalent to F calculated because you calculate the F. And then what you have to do with that F value, you want to compare that F calculated with the F value from the table, which we term as critical F. Okay, so now it's the same, like, I mean, the pattern is about the same with other tests. You calculate something like a parameter and you compare with the value from the table. And from there, you make a decision, okay, based on the decision rule. So if you see the decision rule below, so if the F calculated is less than the F table, so you conclude null hypothesis. If it's the other way around, you conclude alternative hypothesis, right? So that is the decision. And the last step is to make a conclusion. So how to make a conclusion? You have to go back to your hypothesis. So state specifically the treatments, what kind of what treatments that you are comparing. So you have to say maybe there is a difference. There is depending on your decision. So there is a difference or there is no difference between group, whatever that, you know, the specific group or treatments. Okay. And for finding the critical F, you have to know how to use this table. This is another table that you have to know. It's called F distribution table. It's used for finding critical F, okay, for completing step 12. So this table, I think I have uploaded this table in Elib. So if you see, if I can enlarge this. Okay. Okay. Hold on first. First, you have to know that you have to have the degree of freedom for the treatment. Remember from the table, you have the degree of freedom for the treatment and also the degree of freedom for the error. So those two values, for this one is the symbol in the table. This one, if you see that symbol, you know. So this one is what is the name of it? It's theta. Okay, this symbol, that refers to the treatment, which is the horizontal or the row, the one here. Okay, and for degree of freedom for the error are the values that you refer to the first column. Okay, so don't get mistaken for that. So based on that two values, you have to find the F value. But again, here, if you see, now I will enlarge this. So you will see that there are two values, actually, two values for each of the point. Yeah, for example, here. So the first row here is not bold, isn't it? So the second row here, you can see that the values are bold. So what is the difference? For the Roman type, for the non-bold one, that refers to when alpha is equal to 5%. Okay, so and for the bold one is when alpha is equal to 1%. So it means that depending on the alpha value given in the problem, you have to be based on that. Okay, if let's say the alpha is 5%, then you refer to the non-bold one. Okay, the values of the first row for each of the point. Okay, right. Hope that's clear. So those are the steps for ANOVA. Okay, yeah, so once you find the critical F, so this is actually whatever the values here, these are the F critical. Okay, so once you get the F critical, then you proceed with step 13, compare the F calculated and F critical, and you make a decision based on this rule. Okay, and step 4 is you make a conclusion. Okay, now those are the steps. Those are the steps. So let's have a look at the problems in lecture 1. I'm not going to go through all of this because you know, I've highlighted the main points. Yeah. Let's have a look at the example here. Okay. So this is an example given. Table below is nitrogen and level of UC0 Gregory seedlings after applying 5 different types of fertilizers. Do the above data present sufficient evidence to indicate a difference in the mean N level for the 5 different fertilizer at alpha equal to 0.01? Okay, now. So why is important for you to understand the problem? So here, what are the things that you want to compare? You want to compare the nitrogen level is a factor, isn't it? This is the factor. Factor. Okay. And it's on one factor, obviously. And you want to compare 5 different types of fertilizers, but you have this thing, control. Remember, in any experiment, we must have a control. So it's quite a trick here. It's not actually to just compare 5 different types of fertilizers. It's actually 5 plus 1. Because you have 5 different fertilizer, A, B, C, D, E, and you want to compare with the control. So actually the number of treatments, remember treatments, now in ANOVA we call samples treatments, okay? And this is also called samples, but we don't say samples anymore, or groups. These 3 things are actually equal. So it's actually not 5, it's 5 plus 1 is 6. So if you don't understand the problem, you just accept everything, you know, you just accept the words literally. So you would take 5 because you say that 5 different types of fertilizer. What is this control is all about? So you still want to compare with the fertilizer. So actually in general, the whole number of treatments is 6. Okay, and this problem is not difficult to understand, right? I mean, it's a very simple thing. So please make effort to understand the problem before you solve the problems. Okay. So so now you know that you want to compare. These are all the nitrogen level. These are all nitrogen level. So kena faham lah apa benda yang you compare. Kalau tak, you akan lost. You tak tahu hypothesis nak cakap apa, and then you do not know what to conclude. Apa sebenarnya? What is the purpose of doing the analysis? Okay. So that's the thing. Okay. So here is nitrogen level are the values inside. Okay. Now, what is actually our objective? We want to know for every groups, for all these 6 groups, is there any difference? Is there any difference or not in the values, in the mean values? Right? Remember, for every sample, we represent the whole sample with the mean value. Means that for treatment A, at the end we want to compare the mean value with mean, because that's the value that represent the whole group, right? So now we have to know that later you have to find out what is the mean A, mean B, and so on. Okay, so in basically we want to compare how these mean values differ. Is there any difference or not? Okay, that is the purpose. And why here we use ANOVA? Because obviously there are 6 groups. 6 groups, 6 is more than 2. So we cannot use t-test. We have to use ANOVA, ANOVA test. So that is the basic thing that you have to understand before you solve this problem. So you have to use ANOVA test, and it's one-way ANOVA because we are just comparing the nitrogen level. It's only one factor. There are no two factors. One-way ANOVA. So that's why you use one-way ANOVA in this test, in this problem. Okay, so how to solve this? So when we apply all the steps just now, the first step is to set the hypothesis. Yeah, I add some more. There's no difference in mean level of all the 6 treatments. I think this one because it should be updated this sounds. There are differences in the mean level of okay. So please take note, you have to add this specifically. So how you want to construct the hypothesis? So when you understand the problem, you will not say that there is no difference. There is a difference. Difference of what? Difference of what? So you have to mention. Kalau macam ni, the null hypothesis always say that there is no change, no difference. So you are comparing the mean again, right? So the mean of n level. See, so see how specific it is when you have to construct the hypothesis. So the null hypothesis says that there is no differences in the mean n level in Belian. You just copy from the problem there of all the 6 treatments. Okay, or maybe you want to say of all the 6 treatments, you want to say mention specifically also can lah fertilizer A to E and also control. But if you say 6 treatment also can. Okay, so this is what I mean by specific statements, hypothesis. Yeah. So don't just say no difference, there is a difference. Okay, so step 1 is done. Okay, step 2. Now you have to construct this, you have to construct in your workout this table, and you have to find out, actually this value is also the one that you have to solve. Everything here is not given actually. ABC. I'll update later. So now when you construct the ANOVA table, you have to know that these are the values that you want to solve. Okay, right. So how you want to solve that? Okay, the first thing is to solve the degree of freedom first. Degree of freedom, okay. So for the treatment, degree of freedom is equal to here. This one is equal to n minus 1. Okay, and for the degree of freedom, this one, t minus 1. So degree of freedom, this one is t minus 1. Okay, what is t? T is number of treatments. Okay. T is number of treatments. Okay, you always start with solving the df first because you go from in this table from the left to the right. So at the end you will solve the f. Okay. So here treatment t minus 1, number of treatments. So the treatment is 6. Okay. So means that the degree of freedom of the treatment is 6 minus 1 is 5. Okay. So this is the one here. For the degree of freedom for the error, this one is equal to n minus t. So this is a formula separate. So n is the total number. N is the total number of points. So here we have 6 treatments, and in each of the treatment, they are 1, 2, 3, 4, 5. So 6 times 5 is equal to 30. So there are 30 data points. This is what I mean. Yeah? So n is 30. N is 30. So 30 minus 5, 30 minus 6, sorry. 30 minus 6 is 24. Okay, so that's how you solve for the degree of freedom for the treatment and degree of freedom for the error. Okay, those are the 2 things that you solve. Okay, and then what you have to solve? Sum of squares of the treatment. Sum of squares of the treatment So I don't know why this in this example this one is given, but normally you have to solve everything actually. Okay, so how you want to solve for SST? This is actually SST, and this is SSE. Okay, if you go to the steps here, this is actually what we have done just now. So, so from this step 3 until step 9, okay, so here, how you want to solve this one a bit tedious. So remember that you have this data given to you initially. Okay, so these are the data given to you, which is the same as the problem lah, fertilizer A until the control. So if you see 19.4 to 17.3, these are the data. So what you have to do, you have to create additional column like this, okay? And then to solve for this term, okay? So what you have to do first, you have to find what is the mean for every treatment. Okay, so yi bar. Okay, yi bar. So it means that 19.4 plus 32.6 plus 27 plus 32.1 plus 33 divided by 5, you got this. So this is actually the mean of each treatment. Okay, and y is the referring to every treatment lah, like treatment 1, treatment 2 until treatment 6. We have 6 treatments. So these are the mean of every treatment. So you solve this one first. So once you solve that, you have to solve for the overall mean. So how to find the overall mean? So y double bar, you see this one double bar. So means that you just add up 28.82 plus 23.98 until 18.7 divided by 6, right? So you got 19.887. So that is the overall mean. Overall mean. Okay, those are the two things that you solve first. Okay, now in order to solve this thing, so you see here there is y double bar. Okay, you have calculated the overall mean, which is 19.887 in this problem. And if you see the term here, yij minus y double overall mean, and the whole thing is square, isn't it? So what does yij means? Yij means here is referring to each of this point. Okay, means that for this one, 19.4 minus y bar is overall mean is 18.7 squared. So you got 0.236844. Okay, and you solve for every point. Yeah, so I know it's a bit tedious, but this is these are the steps of it. It's actually until here. So if you see 1, 2, 3, 4, 5, 6. Yeah? So you have additional 6 columns that you have to fill in the values for this term. Understand? Any questions so far?
No, doctor.
Okay, so these are the values. You know how to solve this. Okay, now what you have to find next. So this one, once you have solved the 6 columns, so for every row, what is this value is all about? This value. This value is the summation of the row. For example, here, 0.2368 plus 4.78 plus 8.33 plus 0.66 plus 31.2 plus 6.69 is equal to 51.91. Okay, so these are the values summation of row values. Okay, means that you solve for every row, you got these values. Okay, so why you have to find these values? Because if you add up all of this, add up vertically like this, you will get these values. And this is TSS. Okay, TSS. And this TSS is the values that you have to solve here. SS. Yeah, this one. Okay. So if you see, we have solved this one, we have solved this, we have solved this. So in order to solve TSSE, a bit two other steps tadi lah. So this okay, TSS. So what was next? The next thing that you have to find out is SST. Okay, so how to find SST? So this is the formula. Summation of n multiplied by y bar minus overall mean square. So how to solve this actually is summation is the summation n. So n is 30. N here is referring to the number of the size of the treatments. The size of the treatments, which is 5. If you see 1, 2, 3, 4, 5. So means 5 multiplied by the first treatment, 28.82 minus the overall mean, which is 19.887 square plus 5. 5 is the, all of the treatments have the same size. So 5, and then the second one is 23.98 minus 19.887 square plus, until you solve for the last one, 18.7 minus 19.887 square. Okay, and when you add up, that is the value here, which is SST. Okay, sum of squares of the treatment. Right, so once you have solved the SST, so you know already the TSS, you don't have to apply this formula actually, because SSE is equal to TSS minus SST. So you will get the SSE values. So you must have actually, so every value that you solve in this table, it will affect each other. So if your SST is not correct, then it will affect the SSE and so on. Okay. So that's how you solve SST, SSE. Okay, now what else? You have to solve for the, remember the table again. Okay, now see. So you have solved for SST, SSE, and also TSS. So MST is the mean square of the treatment, is equal to SST. This is actually SST. SST divided by the degree of freedom. Okay, this one is actually SST divided by degree of freedom for the treatment, which is T minus 1 here. So MSE, SSE divided by degree of freedom for the error. Okay, so this part is a bit simple because you already have the SST and SSE values and you just divide with the degree of freedom. So those are how you got the MST and MSE. And then F value is equal to MST divided by MSE. Yeah, once you get this MST, you divide it with MSE, you got the F value. So I think the tedious part is how you get the TSS, SSD. That's why you have to have that additional columns just now. Okay. So if you're not clear with this part, let me know, because you should do this actually in order to solve the summary table. Okay. So what I can conclude here is first, find the mean of each treatment. That is this one. Okay. Okay, that's the first thing. Second is find the overall mean. Which is this. Okay. The third one is solve Yij minus y bar square, which is this. Okay. And then you solve for number 4 is you solve for TSS, right? TSS, which is TSS, which is this. And then from there you can solve for SST, which is this one. And you can solve for that. Once you got the SST, you can solve for SSE. SSE. This one. Yeah? Okay. Yeah, so it looks complicated, but if you know which one first, then you have to practice lah. This one needs practice. Okay. So those are the things that you need to find out from this part. Okay. So now let's go back to the problem. So now we have solved until F value. Once you have find out MST, MSE, and F value. So we are done with F calculated. So what's the next thing? We have to find the critical F from the table. Okay. So remember the degree of freedom that we have solved for the treatment is 5 and for the error is 24. So we are given the alpha 0.01. So we have to refer to this value in the F table. Okay, so now let's go to the F table. So 5, 24, 0.01. Okay. So for the table, 5, 24, and 1%. Okay, so now we need to use this. Degree of freedom, the first one is 5, isn't it? So 24. This is not let me go to the full version of the F table. Okay, so this is the full version. So we have to refer just now to 1%, 5, and 24. 5 and 24. Okay, it's here. So 1% tadi a volt. So this is the value. Okay. So it's the F critical is 3.9. Okay, so that's how we solve for the F critical. Go back to the problem. 3.9. Sekejap. Where's the 3.9? Itulah 3.9. Okay. So this is the F critical. Okay, this is the F critical. And then step 5 is to make a decision. we compare, and this is the rule that you have to know. Okay, so our F calculated is 14.37. This one, this one. 14.37, and F critical is 3.9. So means that it falls under this situation, right? This decision. So means that we have to reject the null hypothesis and we have to accept the alternative hypothesis. Okay, so you can say that we accept the alternative hypothesis. So that is the decision. So conclusion, you have to construct a proper sentence. So means that we refer back to our hypothesis. It says that there is a difference in the mean and level in whatever the things here. You see the resilient vagary seedlings among the treatments. Among the 6 treatments. Right? So this is the conclusion that you have to write. So there's a difference. Yeah? Okay, any questions? So this is ANOVA analysis. Okay, for part 1, for lecture 1, you have to know how to apply all this stuff. I think this is a you refer back lah to the number of steps, because in the summary of steps ni dia ada banyak steps tu kan, but at the end we want to go through this stuff until you make a conclusion. I think the number is not really the same, because here it's just a simplified one, so that's why you see here the step 6 is conclusion, but it's actually to complete all this stuff, because here we include all the things inside here, which is the summary table. Okay. Any question before we proceed with part 2? You have to understand this part very well, because that will influence your understanding in part 2. So that's why I want to repeat this part. Okay, any question? This is part 2 for today.
No, doctor.
Okay. Right, so if there's no question, if it's clear for you, then we continue with part 2. Okay, so ANOVA is not yet finished until the last point that we discussed just now, the conclusion. So if you see back just now here, the conclusion, there is a difference in the mean and level among the 6 treatments. So if you understand it, if you try to think deeply on that sentence, it's not yet very conclusive, because now you have 6 treatments, right? You have 6 treatments. So means, let's say there are 6. 1, 2, 3, 4, 5, 6. A until E, and then we have control, isn't it? So means that there is a difference, but we do not know actually where the difference lies. Is it between A and B? Is it between B and C? Is it between C and D? D and E? E and control? Or control and B? Or control with, like we do not know where actually the difference lies. So the statement that we construct here for the conclusion is very generic. Generic means it's just generic secara am. Okay. So what we want to know more, if let's say we want to know more, we want to have a better picture about the data, we must find out where is the difference. So before this, when we talk about t-test, we just have 2 samples, isn't it? We just have 2 samples. Let's say sample A and sample B. So when we say that there is a difference between sample A and B, so it's very clear that it's between A and B, there's nothing else. there's no more other samples. So we know that A would be different from B. B would be different from A. And yeah, that's the end, isn't it? But when we have more than 2 samples, and when we say there is a difference in 5 samples, we actually do not have any much idea about where the difference is. It between A, B, C, D? Yeah. So that's the thing that we have to look for after we finish the step for the ANOVA test. Yeah, after we reach this point when we accept the alternative hypothesis and we know that there is a difference, we must find out where is the difference. Okay, so that is the thing that we are going to cover today. Okay, part 2. The subsequent test after the one-way ANOVA is called post-hoc test. Post-hoc means post is something after, right? So so once we have done ANOVA, so we have to know after that where is the difference. That is actually the point, the idea of post-hoc test. Okay, and having said that, this post-hoc test it should be only done only if we accept alternative hypothesis. Means that only we know that there is a difference. So if let's say we accept, in the case where we accept a null hypothesis says that there is no difference. So that's the end, isn't it? So we don't have to find the difference. So in that situation, we don't have to do post-hoc test. Okay, so post-hoc test is only done only if we accept the alternative hypothesis for that problem. Okay, so that is post-hoc test. So means that here we are going to proceed after the ANOVA. We're going to proceed with subsequent investigation in order to find which pair is different. Okay, like just now, if let's say we have 6 treatments, then we would like to know in detail, by doing some extra analysis, where is the difference? Is it between fertilizer A and control, fertilizer A and B, B and C, D and E, and so on? Okay, there are various combinations, isn't it? We're talking about pairs. So that is actually the purpose of post-hoc test. Okay. All right. I think I have done the introduction. Okay. Done when there is a significant, when there is a difference, or in other words, when alternative hypothesis is accepted. Okay, right. So in the case where you just conclude null, you don't have to proceed with post-hoc test. Okay, significant ANOVA, the mean ANOVA. Okay, so this is null hypothesis. So when we if you want to mention specifically, because we are talking about the mean, you can also express the null hypothesis in this way. Yeah, mean 1, mu, this is mu, this term is mu, we call it. Mu1 is equal to mu2, or like you have to mention, like if let's say it's fertilizer A, right? I have to mention, but this one is just a generic form. So that is the way how you can also write the null hypothesis. Okay, alternative hypothesis says that at least one of the means is not equal. At least one. So means that there, if let's say you have A, B, C, D, E, and then let's say we name it F, right? Okay. So what does it mean here? At least one of the means, this is means is not equal. So means let's say A and B is equal, B and C is equal. Okay, so let's say there are many combinations, but there's one pair that is not equal. E and F not equal. Okay, let's say this is the situation. So the whole thing here, it makes this the situation fall under the category of alternative hypothesis, because at least one of the means is not equal. So means that unlike if let's say you have everything equal, then it is null. But if let's say you have one, at least one is not equal and the rest are equal, that enough to make the whole situation or the whole data falls under alternative hypothesis. Understand? No. So that's why we need to find which pair is not equal. Okay. So that is the rationale or the reason why we do the post-hoc ANOVA test. Okay, because ANOVA, the steps that we have gone through just now, does not tell exactly which means are significantly different from each other. So that's why we have to do post-hoc tests. Post-hoc test can only be used when ANOVA found a significant effect or when the alternative hypothesis is accepted. Okay, I've mentioned about this. Okay, if not significant, do not go further with the analysis. Means that if you accept the null hypothesis, there's no point for you to proceed with the post-hoc test. Okay, that is the basic of post-hoc test. So what are the 4 types of post-hoc tests that we're going to have a look today? There are 4 types, but we only focus on the last 2 after this, which are Tukey test and Bonferroni test or Bonferroni method. Okay. Now let's have a look first at the 4 types of post-hoc tests. So this is just for you to know the first 2. The first one is least significant difference. That's the name of the test, or Fisher's LSD. Okay, so this is among the earliest tests invented by the statistician. Not generally favored, but used with caution. Okay, it's just some introduction lah. You can read, or you can yeah, you can read the background. I will not focus that really much on its use. Huh? Okay, the second one is Schaeffer test. Schaeffer test is used with unequal sample size. Less powerful. Okay, the reason why the first 2 tests are not used because the test might not be perfectly designed. Okay, so there are some weaknesses. It might be not strong. So in statistics, when we want to say that when we use certain tests, is because that test is capable to give better picture. Okay, that's why those tests are favored over others. Okay, so enough to say that these 2 tests, maybe they are among the earliest tests invented, but they are not that really strong, or they are not that really capable to give enough conclusion at the end. Okay, but you can have a look at this. Okay, the third test is Tukey test. Okay, this one is the one that we're going to focus after this. So Tukey test is used when the sample size are equal. So what is meant by the sample size? The sample size is when, if let's say you have just now A, B, C, D again. So each of these have, let's say, 4 points. Yeah? And also like this. So each of these have 4. So it means that the whole thing here, the sample size are equal. Okay. But if let's say you have one that is, let's say, 5. And here are the 5 you got. But C and A has 4. So the whole thing here, we can say that unequal sample size. This is sample size, eh? Unequal sample size. Okay, so Tukey test is used when the sample size are equal. Okay, when the sample size are equal, so you use Tukey test. Right. Bonferroni method, it can be used for both situations, when the sample size are equal or when the sample size are not equal. So it can be used. So it means that it is more flexible than Tukey test. But if the sample size are equal, although Bonferroni method can be used, but actually Tukey method will be better, actually. It's superior to the Bonferroni method. Okay. So that's the difference between Tukey and Bonferroni. Okay, now let's move directly to Tukey test. Okay, so we are going to focus more on Tukey and Bonferroni and not the first 2 to start. Tukey test. Okay, Tukey test. So what you have to do for Tukey test, okay, remember these two tests, Post-Hoc tests. So these are done after you have done ANOVA test. So this is what is meant by here. So it means that you have generate the summary table, you have come to the conclusion, and in your conclusion you say that you accept alternative hypothesis. Okay, so this is then you proceed with the post-hoc test, and it depends on the problem whether the sample size is equal or not. So if it's equal, you can use Tukey test. If the sample size is not equal, you can use Bonferroni method, Bonferroni test. So this is meant by this first one, calculate and analysis of variance, is you have gone through what are covered in lecture 1. Okay. Now, when you proceed with the Tukey test, what you have to do next, what you have to do after you have done the ANOVA table, so you have to select two means and note the relevant variables. Okay. So what is meant by select two means? Okay, let's say you have, I give the easiest one. Let's say you have A, B, C, D. Those are the 4 treatments. Means that now you want to know more, right? Which treatments are similar, which are not. So you have to match, you have to create like all the possible combination of pairs. Maybe like A and B, A and C, A and D. Okay, so for this one, B and C, B and D. And the last pair, the possible pair is C and D. So altogether we have 1, 2, 3, 4, 5, 6. There are 6 possible pairs. So this is meant by select two means. Because after this we are going to calculate certain values, and that values will determine whether each of these pair has a significant difference or not. Okay, but at this point, this is what is meant by that. Okay, select two means you have to create possible pairs. So the order is not considered. If let's say A and B is equal to B and A, because we're just talking about the pair here. Okay, so what you have to do, you have to list down all the possible pairs. Okay, that's the second step here. The third step for Tukey test, you have to calculate this value, the critical point, which is equal to Q multiplied by MSE divided by R. Okay, now, so MSE is the MSE value that you got from the ANOVA table, because you have performed the ANOVA test, right? So that's meant by the step 1 here. So from the ANOVA table, get the MSE, put it in this formula, but you have to know what is the Q and R. So the Q is the critical value at the alpha level for the studentized range distribution. Okay, so this is another table that you have to know. And the table is called studentized range distribution. Okay, that's Q. And then R is the sample size at each level. The sample size means that how many points every treatment has. Okay, MSE is mean square error from the ANOVA table. So because this one is Tukey test, so it should be equal the sample size, because Tukey test is only for the equal sample size. Okay, now R and MSE is quite, you know already how to find it. So how to find Q? How to find Q? Okay. Let's have a look at first at the steps here. So the fourth step is to arrange the mean. I would say that step 4 is not that really critical, because okay, just digest it, just arrange the means in ascending order. Step 5 is to compare the mean difference with critical point. Okay, let's go through first. I'll show later what each of these mean. And then final step is to make a conclusion. Right, the decision rule here, this is the decision rule, means that you have to compare the mean difference with the critical point, which is this one. This one. Okay. And for each pair, you have to find the difference of the mean. Okay. Right. The decision rule says that when the mean difference is less than the critical value, you accept null hypothesis and the other way around. Okay. And finally, the conclusions that you have to make is to state which pairs have a significant difference and which pairs do not have a significant difference. I know that is a bit complex for you because just now the ANOVA itself is already such a 20 steps, and then this one pun ada lagi tambah. Okay, let's have a look at how you want to solve it. Okay, so we are referring to the same example. Remember just now we are talking about the fertilizer and the control, right? And we are done with the ANOVA steps. And our conclusion just now is that we accept the alternative hypothesis. Okay, here. Okay, assuming that we have solved the ANOVA tadi. But in real situation, you have to start from ANOVA. Okay, from ANOVA, from all the steps in lecture 1 or part 1. Okay, so just now remember we accept the alternative hypothesis means that there is a difference in at least one of the means of the treatment. So from here we know that we have to proceed with post-hoc test. Okay, so post-hoc test between Tukey and Bonferroni, which one to be used? So here we see that the sample size is equal, right? 5 for every treatment. So we have to proceed with Tukey test. Bonferroni also can, but then remember for the situation where the sample size is equal, Tukey test is actually much better than Bonferroni, although Bonferroni can be used. Okay, so for that reason, use Tukey test. Okay, so the next task is to find which means are different. So that's why you have to do the post-hoc test. You want to know whether A and B, B and C, D and E, or what? Okay, so we proceed with the post-hoc test. So means that if we want to refer to the step, we have to proceed with step 2 and above. Step 2 and above. Okay, now. Okay, step 2 is actually to list down the possible pairs just now. So means that step 2, if you want to step 2 here, A and B, A and C, A and B, A and E, A and control, B and C, B and D, B and E, B and control, this one is part 3 function state, B and control, and then C and D, C and E, C and control, D and E, D and control. That's the end. Okay, so those are the possible pairs. Pair ada dua kan? Pair, so that's why there are 2 for each. So that is actually step 2. Step 2, select 2 means. And then step 3 is to calculate the critical point by applying this formula. So from the previous ANOVA table, you know MSE, you know what's the R, the sample size is 5. Yeah, R is 5. And then apa lagi? Q. Okay, you have to find what's Q. Okay, Q. So means here, right? So the MSE is, if you refer to the table, the value is 11.79. R is 5. So how to find the Q? This Q. This Q. So given to us, what's the alpha value? Okay, 0.01. It's 0.01. Okay. So this is the studentized range distribution table. This is a table that you use to find the Q value. Okay, and this is actually referring to the Q. The whole thing here is Q value. Okay. Now, you know what is N and B? Okay, now here, yeah, it depending on your alpha value. Let's say this one is 5% or 0.05. Here is 1% equal to 0.01. Okay, now if you see this table, you need to know what's the B and what's the N. Okay, N is the number, here is the number of treatments. N is number of treatments, which is 6, right? Because we have 5 fertilizer plus 1 control. Is 5 plus 1 is 6. And then B is the degree of freedom. Degree of freedom of the error, actually, which is actually the total number of observation. Okay, minus number of treatments. So which is actually 30 minus 6. That's why you got 24. So we got 24. Or you can see the degree of freedom of the error. Okay, ambil terus pada error tu, which is 24. Okay, so by knowing these two values, 6 and 24, that's how you refer, you refer to when you are finding the Q value. Okay, N is 6 and B is 24. Okay, 24 is here. Okay, 24. So the value is, this is the Q value that you are looking for. Okay, so Q value, so you substitute into this formula. Okay, let's say it's this one is what? Oh yeah, so this one is for 5%. Okay, there are two tables. So this one is 5%. Another table is 1%. So you have to refer to the right table, and you have to refer to your alpha value given in the question. So if it's not given, you define by yourself. Okay. So for this one is 24 and it's just now 6, so it's 5.37. Okay, so it's different based on the alpha value. So that's why this value is different. But this is the Q value, Q value that you got from the studentized range distribution table. So you solve for this critical value. The whole thing here is critical value. You don't have to solve for 2, but this is just to show how you find for the 2 different alpha values. Okay. Okay, now, so you have solved the critical value, which means that you are done with step number 3. Okay. The next one is to, actually you can go to step 5 directly. Okay. I don't prefer step 4 actually. Okay, let's go to step 5. Compare the mean difference with critical point. So now, so here, remember the possible pairs of all the possible pairs A and B. Okay, this one is because of it is designed with ascending order EC, E control, ED. That's why you have this order. But if let's say you just now to make it easy, you can just go for A and B. Kalau ikut order yang the actual order A and C, A and B. You can put fill in this with all the possible pairs that I've listed just now. Okay. So what you have to know, I tak prefer yang punya step 4 ni sebenarnya. Okay. So let's say you opt my method, A and E just now, A and control. I think this is much better and easier. B and C, B and D, B and E, B and control, C and D, C and E, C and control. D and E, D and control. That's it. Okay. E and control. Okay. Let's say you have these possible pairs. Okay. Pairs. And then you have to find the mean difference. What is meant by mean difference? So for each treatment, it has the mean value, isn't it? So the mean value of A is 28.8. Mean value of B is 24. I think you have to solve this when you solve for the ANOVA in the previous steps, right? So you have these values already. And then the difference is 28.8 minus 24 is 4.8, isn't it? So you have to solve for the difference of the means for every pair. Okay. Right. So that is the mean difference. It's actually the same with this one, but my method here is I just use the order from the actual order, not according to ascending order, which I think is not confusing and it's much easier. And you follow my method because I'm the one who will mark your exam paper. So yeah, so the mean difference, and then you find all these values. It's actually given here, actually 4.8. A and C is A and C 14.2. Okay, 14.2. A and D 8.9. Okay, so you know lah what is this mean difference, huh? Right. So the next thing here is to conclude. Okay, so what does it mean? So if let's say we use alpha 0.01, okay, and our critical value as what we calculated before is 8.25. Okay, say 8.5. You just solve for one value, one critical value only. Tapi dalam contoh ni, both are given just to show how to find the critical value under two different alpha values. So what you have to do is what you have to mention in the conclusion part here, or decision. This is actually decision. So remember the decision rule. If we go to the decision rule, so when the mean difference is less than the critical value, you accept null, and the other way around, you accept alternative hypothesis. So it means that you have to compare the mean difference with the critical value. Okay, based on this decision rule. Okay. So means here, if let's say your critical value and your alpha is 0.01, okay, you compare with 4.8. Which one is smaller? Okay, which one is smaller? Means that here decision less. Okay, decision here is less. You accept now. So if for this one, you accept null, and you do the same for the whole pairs. So here you will see that there are some that you accept now, you accept alternative, okay, and it will be different because the values here are different. Okay, so that is what is actually all this this column is all about: accept null or reject null. So to make it easy, you just refer to one similar hypothesis. If let's say null hypothesis, just null. Okay, you see, accept null, reject null. So it's not confusing for you. Okay. So these are the results. You can see some reject, some accept. So it means that if you want to analyze specifically for pair A and B, you accept null hypothesis. Means there is no difference between mean A and mean B. So now we know by having this post-hoc test, we can exactly know for every pair, which pair actually that has a difference, which pairs that do not have a difference. So this is the purpose of post-hoc test. So this is decision, actually, not conclusion here. So finally, you have to make a conclusion. Okay, again, This one I tak prefer step method. It's very confusing. So make a conclusion. What I expect you to come up with at the end is to conclude which pairs that have a difference, have no difference, and which pairs that have no difference. Okay, based on the decision here. Okay, for example here, accept null means there is no difference, right? So the conclusion, it should be a bit lengthier because you have to mention all the pairs. Okay, let's say in conclusion, how you construct the conclusion. In conclusion, there is no difference for between pair, say between pair. So no difference means the one that accept null, right? A and B. You just choose which one you accept. B and D. Accept me okay. B and control. So list down all the things that no difference, and there is a difference. There is a difference for pair. For example, A and D. A and control. Those that reject the null. Okay, so it means that there are two important points that you have to mention in your conclusion. Pairs that have a difference and pairs that do not have a difference. Okay, that is the conclusion. So here is not yet conclusion. When you accept or reject, that's the decision. This is decision actually. This is decision. Okay, so you follow my my style for it. You don't have to, kalau kat sini dia a bit confusing lah, you nak arrange lagi and then have to, but it's just that if let's say you want to put it in a table, okay, how you present it, normally how the statistician present the data. So they would present like the mean values and also the groups. For example, like here we have for A until control, okay, and the mean values, and they would denote that those with the same letter, okay, let's say are not significantly different. So means that, for example, this one. What is meant by same letter, they would denote with letter A until ni lah, sampai mana. So for example, it starts with A until C. So means followed by same letter are not significantly different. So say you analyze from the pairs here, you would see that pair EC, E control, and ED, they have no significant difference. So you name it as A. Okay, and then another group is the one that is another group that do not have significant difference is treatment BD control. So this is actually based on your observation, okay, but this is how the statisticians present the data. Okay, but for your level here, I would expect you just to come up with the statements like these two statements that I mentioned. Okay, I think that's enough for you at this point. Okay, so any question? I know it's a bit tricky, but you have to go through carefully this step. First ANOVA and then post-hoc test. If you go through all the things in proper way, it's not that really difficult actually, but it needs practice. You need to do lots of practice. Okay, so that is post-hoc test. So at the end, you want to conclude which pairs that do not have a difference, which pairs that have a difference. Yeah? So you can see that the difference, you can see it will give you more details rather than just the ANOVA table, ANOVA test. Okay, can we have a 5 or 10 minutes break before we proceed with Bonferroni? Or is it too much already for you? Or if you don't want to proceed with Bonferroni, we can proceed in next lecture because I feel that it's too much for you to digest. Okay, it's fine. Because we still have ample of time for the final exam. We only have this and then LU4. LU4 is not that much. I will proceed next lecture lah, Bonferroni. Too much. Okay, next lecture. Okay, so today we cover until Tukey Test, Tukey Test. Okay, so up to this point, what you have to know about LU3 ANOVA Part 1, okay, all the steps, tapi it's not yet complete. You have to see whether during the ANOVA test too, whether you accept null atau accept alternative. What is meant by accept null? There is no difference. So you don't have to proceed with Post-Hoc Test. Means there's no difference, all the same. But if there is a difference, means that you have to proceed with Post-Hoc Test because you want to know exactly where the difference lie. And for that, you have to identify which test that you want to use, Tukey or Bonferroni. Tukey is for equal sample size. So you have to know what is sample size, the size of every sample. For Bonferroni, it can be used for both equal and unequal. But for equal sample size, actually, Tukey test is way better than Bonferroni, even though Bonferroni is applicable for both. So in short, I can say that you can apply Bonferroni for unequal sample size. Okay, we will cover next week for this one. Okay. So Tukey test study on all the steps that I've mentioned. Okay. So you can do exercise on Tukey test. I will, if I have the question, I will post on Elite. Okay. So I think that's it for today. If you just stop until Tukey test. So we'll proceed Bonferroni next week. Any questions so far? Or you're not yet into it, so that's why you don't have a question. Okay, go through first. If you have any question, you can just email me. Okay, thank you for your attention today. Yeah, okay, I understand. You are still digesting it. Go through. You can watch again the lecture, this recorded lecture. Okay, and then if you have any questions, you can just email or you can ask next time. Okay, thank you very much for your attention. That's the end of today's lecture.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
You're
Thank you,
welcome.
Doctor.
Thank you, Doctor.
Yeah, welcome. Have a nice day.
Hello, Doctor. I haven't scanned my attendance.
Oh, attendance. Hold on,
Doctor, I'm using my phone, so can I do manual?
Okay, what's your name?
Zulfaka.
Zulfaka. Zulfaka. Okay. Okay.